Hello, hello. Welcome to Houdini Hangout. It is the 19th of April. So glad to have you with us tonight. We are going to be playing around with some Vellum, hopefully. That's the idea, at least here. I had somewhat of an idea for like doing some sort of like a tornado and having it kind of like suck up particles into like a vortex, and thinking about a little bit of how to source that so that it doesn't just pick up all the particles and have nothing on the ground, but then not just like constantly sourcing particles from the ground as well. So I had a couple ideas for that, or an idea for that. So that was kind of what I was hoping to set up tonight and mess around with. So yeah, my name is Peter. I am hosting Houdini Hangout and have been since the beginning. If you are interested in chatting about anything, please drop some messages in the chat. I would love to hear from any of you that might be watching, and if you have questions or suggestions, please put them there as well. I'm certainly not the foremost expert on Houdini. I've been using it for several years now, but I would just not going out there to say that I am the be all end all. I do know some things about it, but I'd love to hear if you guys have better suggestions for ways of doing things. There's always a million and one ways to do everything in Houdini, so you can use just about any and every trick in the book. Hey, yeah, thanks for being here, T.O. there. Looking forward to seeing what we get going tonight. Can't promise anything because I've never done this before, but hey, we'll all try to learn something together, right? Another thing I'm trying this evening is I've got a little chat thing above my head here, so hopefully if you throw some messages in there or you're hearing me respond to something, you'll be able to see it on screen there and kind of know what's going on. So so pretty much my idea here is to take some sort of a force using hopefully some sort of spline curve, create like a deforming kind of vortex that's pulling these particles up, swirling them around, and from there we'll see what we can add in. Obviously add in some noise, things like that to help break it up, make it interesting. I'm thinking probably going to start with some sort of just simple grid with like almost like a kind of like a ball pit of like particles in it. We'll kind of just, like I said, see where we get with it, and love to hear your suggestions if you have any thoughts or anything like that. So without any further ado, let's get started here. Thank you so much to everyone for joining. So first and foremost, I'm just going to put down a grid here real quick. I can just type that in and that'll give me just a straight up grid. Let me just change this over to something where I can see the subdivisions on it, or the divisions on it. I think we're going to put, let's see, what size is this? Let's jump in here. It's about 10 by 10. Yeah, maybe we'll make that a little bit bigger. Let's make that like 20. We'll do that. 20 by 20. We don't need a ton of divisions on this here because I'm just going to have this kind of as like a collision geometry type thing. Going to use it to help kind of source, where my particles are coming from and kind of create like a little bit of a collider to keep them inside of as well. So there is our grid. Let's do so you know what I'm going to do? I'm just going to call this maybe ground. I'll call this geo ground. And I like to color any of my geometry nodes green. Got that from the Applied Houdini stuff not back in the day, but he's really great. You should check his stuff out, Applied Houdini on CG Circuit. Amazing. I was actually just brushing up on some stuff today just to kind of, always nice to go back and refresh on some things. So, all right, we're also going to use a box here, and let's do a Boolean as so. And let's do this. So our box, let's make that a little bit bigger. Let's make this maybe, so let's hit escape and enter so we can kind of see the viewer here for it. Let's do that. I don't know. Let's say this will be 5 by 1 by 5, maybe something like that. 5 meters. Seems a little small. Let's do 7.5. Let's try that. We'll do 7.5, and we're going to do this at 2 because it does go up above by 1 here. So that way it'll just be one unit deep as well. So there is our little like kind of pit that we're going to use to source up these particles from. What I'm also going to do as well is, why don't we just do a volume extrude like so, and we can make this grid have some depth. We can always adjust this and stuff like that, but let's just do a depth of -2 here. So there we go. So this way, if we were to do anything interesting to our grid after the fact, we can always use this to extrude it down. Just as a for example, I don't think I want to start like this, but I could set down like a mountain and perturb this. I will change the instead here. Yeah, there we go. It is doing it exactly. So if we did this and had like something that was a little bit crazier like that, our extrude volume would still extrude down, and we could still get this subtracted out box that we could pull our particles out of. But anyways, we're not going to do that. I just wanted to kind of say why I was doing it this way instead of like making 2 boxes or whatever. Hopefully that makes some sense. We're basically taking the grid and having it extrude downward. That way, whatever we do to the grid will always get extruded downwards by 2 meters. So yeah, all right, so we got a box, we got our Boolean here. The thing that I want to do with the Boolean, in fact, is, let's see here. Let's, instead of just doing a straight subtract, let's do, I want to say shatter will probably do it. Yes, that looks like that will do it. Oh, and as always, I'm forgetting to do my stuff here. So let's, I'm actually going to make something new here. I'm going to do Houdini. Hangout. I'm just going to put this in a new spot. So I will call, let's see, we'll just date this 22-419. And I'm going to just call this Vellum Tornado. Cool. All right. So what I'm hoping I can do here is do a couple things. So let's do an A inside B and B inside A. Hopefully that will give me the 2 different yep, then I'll do that. B outside. There we go. Okay, so I can do, yep, so that should give me what I want. So what I'm going to do here is I'm going to do a split. Split because I will probably use a couple different pieces here. So let's grab the A inside of B, which is that, and B inside of A, which is, or I'm sorry. Nope, sorry. Yeah, those are the ones I want. There we go. It looks like we got some weirdness there. Oh, I know why, because those are probably n-gons, so let's just do this. Let's do, let's only de-triangulate the unchanged polygons. Let's see if that gives us any help. Sure does. All right, great. That's just basically, there were some viewport issues there that were happening because this was like a crazy n-gon and it was probably freaking out. So now our viewport is much nicer. I'm going to turn this off so we can just see. Okay, so that's where we're going to source our particles from right there. And let's do a couple nulls here just so we can see where this is going to go. There's that. Oops. And that. So then from this one here, we should have that. But unfortunately, we're not getting the other spot there. Let me just see here if I'm missing one. Okay, well, I can do this differently than a split. I will just, instead of doing a split, I will do a couple blast nodes. So let's do a blast node here. I was thinking it might give me both of those otherwise, but that's okay. And then we'll do the B inside A, just like that. Great. And then I can do another blast over here, and this will be kind of our ground collider, and I will just do this, delete not selected, but instead I will get rid of this one here. I believe should be good. And let's see. Oh, sorry, my thing has fallen down there. There we go. We do have a little bit of weirdness there. Not 100% sure why it's doing that, but it's okay. We can probably just do a little fuse here. Hopefully that'll clean it up a little. And same thing over here, just to make sure, just to make sure we've got good point numbers and everything, and we're not running into any issues. Just gonna take a look at something here. That's interesting. There is an extra face down there. Interesting. All right. Well, we will leave that for right now. I think we'll be okay. And so we'll call this source, and this will be collider. Oops. All right, cool. So we got a source and a collider geometry here. That should hopefully work just fine for us. Yeah, might need to tweak that, but we'll see. All right, so let's let us do this. We will do another geo node, and we will call this sim grains. Do the purple. So let's go over to here and do an object merge. So we're going to merge in that source geometry that we set up over there. So let's bring this in. I'm just going to hide this so that we're not seeing anything else here. So we'll say get source geo there. Oops, moved down a little too far. All right, so let's do a points from volume. Let's do that. I think that should get us what we want. Sure looks like it is. Cool. So we've got a bunch of points here now that are being sourced from this volume. We got about 61,000. Let's maybe bring that down just a little bit for now, just so maybe we'll do it like 0.15. It gives us about 16,000 points. I mean, it should be fairly fast, I think, but I don't want to go too crazy from the start and be dealing with, a struggling simulation or whatever. So let's see, source type geometry, just make sure this is good. Yeah, there we go. That's what I want, is a scale attribute, because we want to be able to have a scale on these, because I am going to do something, I think, with sourcing this a little bit later to make sure that we're sourcing points like when they get removed from here, basically. So I want it to be able to be kind of like replenishing itself as they're getting sucked up. So it's kind of like this, like almost like bottomless pit of particles. So let me just do a piece scale. Now this is something from the AE lib, which is really nice. It gives you a quick piece scale preview. And in fact, that is way too big. So let us go back here and go back and change this particle scale radius. Yeah, probably like that is what we want, I would think. Let's just check this. If we go to like 0.1, make sure it's still looking correct. Yep. Okay, so this particle radius scale looks like we want it to be 0.5, and then that'll give us what we want. Let's see if I go even smaller here, if this will be happy with me or mad at me. It's probably going to be really angry with what I just did there. Probably just went really crazy on this. Yeah, let's not do it that. Sometimes I just got a little carried away with myself. 113 million points. Yeah, that's too many. We don't want that many. All right, great. Looks like this is still working. So that 0.5 particle scale radius is looking great. So let's do 0.5. Go back to that. Great. We don't need this. I just wanted to use that to kind of have a little check for what we're going to be doing here. So there's our points from volume. Let us do a Vellum configure grain. And I'm going to do this geometry here. So this should now set up our grain constraints. And what I can do here is copy this point separation here, copy parameter, and I'll put this into the particle size. I believe that should work. Yep, perfect. So that way it's just making sure that it is, you know, seeing that same resolution. We basically have a reference between those two now. So you can see that it's looking up points from volume 1, particle separation. I'm just going to say create points. There's our Vellum constraints grain. So now we've got this grain set up here. So that's looking good. Display as spheres. Great. Actually, we don't even need this anymore because that would have done the any of the dirty work for us. But all right, here we go. Cool. So we've got that. Let's also get the collision geo. Let's do this. Collide geo. So let's do that. Collider, accept. So we can actually put this right into here and let it just kind of go through the stream. Cool. So constraints, great. I don't think we really need to set up any more constraints of any kind. So let's just do this. Let's do a DOP network, because I think I'm going to build this one from scratch, just because I'm not sure if I'm going to need to do any like really weird stuff with it. So this will be maybe a little bit easier. So I'm just going to grab all these, put them in here. This will do nothing right now because it's not set up to. So let's go up here. Let's do a Vellum Object, Vellum Solver. Great. Let's do a gravity force. There we go. And let's see, we'll do a, hey, yeah, good evening to you too, man. Excuse me, I can't talk. Glad to have you with us tonight on the stream. Yeah, we're going to see what we can do with some Vellum. Yeah, I know everybody... yeah, the nodes. There's too many nodes, right? So, well, hopefully this will give you a sense of like what kind of nodes you use to set up something like a Vellum solver. This is actually not too bad with the Vellum solver. Luckily, they only have a few different nodes here. So really, we have forces. We have the object that goes in here. We have our particle forces, and then a post solve, which is our sources basically. So it can be a little daunting to like get into the mindset of working with DOPs like from scratch, but maybe this will give you an idea for how it works a little bit better, and you know, maybe it won't be so scary after this. So I'm going to do a static object here. We're going to use that for our geometry coming in, and let me think, the last thing we want is, well, let me do a merge node here as well. So we'll do a merge here. Actually, in fact, I kind of like to do this. I just like shift clicking those, alt clicking a merge node down, and then doing that. Just make sure the order's right. You want everything in DOPs to go from, usually the left things affect the right. So if you look right here, there's an effector relationship, left inputs affect right inputs. So pretty much that means a static object, which is on the left, is going to affect the right inputs, which is this Vellum solver. These aren't going to affect the static object at all, which makes sense when you think of it that way. But great, I'm going to hit L just to kind of organize this a little bit. I'm going to call this, what am I going to call this? Ground collider. How about that? Could also do a ground plane as well. However, we don't want it to be up at the surface, so we'd want it to be down below. So we can maybe leave that just for right now. But we could also add a ground just in case it goes over the edge or something like that. But all right, cool. So we got Vellum object, got all that stuff. All right, so let's start linking these things up together. So I've got the data coming into these different nodes. Let's just do some put some nulls down here that we can reference. This is a little bit of an easier way to do this. There's actually kind of a fancier way to do this as well, but we can just drop some nulls down here. So this is just going to allow us to kind of reference in our 3 streams that are coming from the Vellum setup, and we can call this We'll call this geo. We'll call this con for constraints, and this will be collide. So there's our 3 different streams coming in, and we can use those to reference. I will come over, I'll come over here. We don't want to hit that orange up at the top. We want it down at the bottom. So let's do our initial geometry. We'll hit this, and we can go to our geo. We'll accept that. And here comes our constraints. Let's accept that. And so now if we do this, it should just fall down and everything's great with the world. Hooray, we did it. So now we want to use this ground collider, right? So let's just try this a little bit different here. Let's do something kind of a little scary maybe, but we're going to do a little expression. So let's do op input path. And what this is going to do is allow us to figure out a path from what's put into a node. So like if I did, you can see right here, there is an example here, right here. It says point op input path, period in quotation marks, 0. What this means is whatever's plugged into port 0 or the first port, 0 is in like the computer science world, is number 1. Whatever's plugged into that, that's what you want to, resolve that path basically. And for here, you might say, well, how on earth could you do this? There is no input for this ground collider. And you're right. So what we need to do is we need to go up a level. So what we're going to do instead of just doing 1 period is we're going to do 2 periods, because 1 period means this node, 2 periods means go up a level basically. Or at least that's how I think of it. There's might be a better like official computer science term for that, but that's how I've always thought of it. So we're going to do op input path 2 dots, and then we're going to do comma, and we want the third input, which is number 2. So let's do that. And then I'm going to do this little quotation mark here. This basically means we want it to be a string. And sure enough, that just resolved. If I hit the middle click here on my like scroll wheel, it goes to object, simgrains, collide. So that is the fancy way of doing it. Now I could have come over here and hard coded it, but now anything that we put into our third input will be in this collision path. And kind of a neat way to do things, I think. And so let's just hit play here. These are all going to settle down in there and just kind of come to a stop. And that looks just about right. Yeah, they just kind of fall down and sit there. Let's just check our collision guide here. Let me make sure. I'm going to undo display geometry. Let's look at that. Not sure if that. So now this collision detection is actually using a volume source to do this. You can see here. Now this collision detection is saying use solver default. I think what I want to use is surface. Let's see if that works. Because what that will do instead is just exactly go up to the border of this. It won't be trying to like create a volumetric representation of it. So let's see if that works. Yeah, seems to be working just fine. Great. Yep. So there you go. So exactly like you're saying there about command line. Yeah, exactly. So it's saying this directory or upper directory. So in this case, it's saying this node or up 1 node. So if we look up here, this is the node that we're now resolving is this .NET 1. And you can see here, this is the number 2 port. So 0, 1, 2, 3. Just like in computer science, that's kind of the way that, indexes work and things like that. I'm actually going to rename this .NET anyways. So let's just call this Vellum Sim. And yeah, so that's kind of the 2 different ways that you could do something like this inside of here. So some of these will have ways that you can grab the ports and all that kind of stuff. Some will actually, some nodes will give you the option to actually do a second context geometry, they call it. So like if you do, let me think what one is, let me just type some random thing. So like if you were doing like RBD packed object, I think has it. Yes. So something like this RBD packed object. So if you were working in RBD, you could actually change the geometry source here to be first, second, third, fourth context geometry. And that just means those nodes that are up here. Those are the context geometries. So that's something you can do as well. This doesn't have that that specifically on it, which I'm not 100% sure why they don't add that on here. It feels like it would be kind of nice. But anyways, that's just something, just kind of a fancy way of being able to do that. And the nice thing about that as well is that if you plugged something else into there, it'll just say, oh, okay, grab that instead. So, sorry, this thing's falling all over the place on me tonight. So anyways, just something to kind of give you a little extra information there. So cool. So that is our Vellum object. There's our Vellum solver. We've got our particles in here. Cool. Oh no, dog is freaking out. Yes, good. Take the dog on the walk. I mean, you can always rewind and watch more of it. No problem. No problem. Glad to have you with us though. All right, so let's now figure out how to do this. You know, some sort of a I don't know, moving around curve force. So we're going to use some pop forces here. So let's build a curve up, and we can start going with that. So let's do another geometry node here. We'll call this geo. Let's call it vortex curve. Sounds fun. Vortex is a fun word. All right, so I'm going to just ghost the other objects so we can see where we're looking at here. And I'm going to go into, I guess 2 views will be fine. Got our perspective here, but let's do a set view front, I guess. And let's just draw a curve here. Or you know what? We don't even need to really draw a curve, I guess. We could just do, never mind, we could just do a line. That'll be fine. So let's do a line instead. That'll be an easier way to kind of go about this. All right, I'm going to turn my points on so we can see what's going on here. And I don't know, let's do it, let's change the length to 5. Nah, it seems like too low. Let's do 10. Let's give that a shot. See if we can make it go that high. I mean, it probably will. I don't see why it wouldn't, but all right, so we've got our line there. Let's just use a resample. I could add points, but this way I know that I'll be getting the set length that I want. So that should be good. Yeah, it could probably be less than that. I don't think it needs to be quite that many points. So something like that'll work just fine, I think. Cool. Let's do a mountain. Oops. We'll do a mountain stop here to mess with this a little bit. I have a feeling that this is working already, and in fact, I can pretty much, I can kind of see that it is, but it's just too small, I bet. So let's do this. Let's really crank that up. Or not. Oh, okay. This is why. So the noise along vector is the issue here. So let me change this back to 1, and let's do the vector attribute. We don't want to do noise along vector because we don't have a vector. We just kind of want to give it some noise, but instead of going in the y-axis, which I really don't want it to be moving in at all, let's just turn that off. That should, you know, deactivate that. We've got these little switches here that'll let us adjust if what component it's using. So we're just going to use the x and the z component of that vector. Let's just see here. No, that looks good. Raw value, 0 centered. Add is fine because that's going to just add into those positions. Let's do animation here. Yeah, that's a great question. So you're asking about why I was using just a Vellum object instead of a Vellum source. So I probably will be putting a Vellum source in there in a little bit. What I'd like for it to do though first is have like a base that comes in that's just like, hey, these particles just exist here. A Vellum source node would normally, let me just go in here and say Vellum source. So this here, if I'm doing like each frame or something like that, you know, this would work fine. To do it, I could just emit it only once and have just one little burst of particles in there, but that's more or less the same as what this Vellum object is doing with the initial geometry and everything. What I'm going to do later is have it source some points into the places where those particles have kind of created voids and stuff like that. And then I will use a source to do it, but I'm going to do a check based on where these particles are and stuff like that and see what's overlapping, because unfortunately in this Vellum source, I don't see any way to tell it that, hey, there's overlapping geometry here. I haven't seen that anywhere in here. And so, unfortunately, that isn't something that is built into this. So what I'm going to do is do a little bit of a check outside of it, kind of reference back in the previous frame and do some things like that to just double check that there are gaps there that it can resource those points back into. Because I don't want it just to be like creating this like pit that's like just overflowing with particles and like pushing particles out of the way and stuff like that. So that was the reason why I'm just using this straight Vellum object first, just to kind of give it a set amount to start with and then go from there. They're both they could both be used the same way, the emission type being only once. That certainly is a fine way of doing it as well. It just seems a little cleaner to have all the particles that I know are coming in to start with on the Vellum object, and then going from there and adding in new particles using a source. So I kind of can separate those two out. That was my it's really so the difference between those two nodes really is that this Vellum object, that is where the data goes, basically is stored to, right? So if we look over here in the geometry spreadsheet, you can see Vellum object is down here. And this is where all of these different things that are getting worked on by the solver go. So you've got forces in here, you've got, different parameters, different constraint geometries, collision geometry, and then here's a straight up geometry for these points. So all of these points are saved in here. If we didn't have this node, you can't do this. This just doesn't work. You can't just put a source in here, like on this node, and have this work. It doesn't do anything otherwise. So the Vellum object is a required thing to kind of store your data onto. And that's really the idea of DOPS, is kind of operating on these objects. You can see down here as well, I have a ground collider. That's kind of its own object as well. So this is kind of like where the data is stored, I guess, if you want to think of it from like almost like a folder structure kind of thing, where like this is your top level folder almost, where everything gets stored inside of, that's getting computed for that. And then things that are happening with the ground collider gets stored in that place. So maybe that helps a little bit with the difference between the two and why I chose to just do it here to start with. So yeah, it can be a little weird, and DOPS is definitely super different than any other context, I think, in Houdini, and can just be a little scary. But I think that's why they've created those SOP level solvers. But in this case, I'm probably going to do some stuff that might freak out the SOP level solvers. So I just like, I'll just do it myself, and just then that way I don't have to worry about it. I might even make a SOP solver inside of the DOP network, which we'll see. I don't know if I need to or not, but I have a feeling that could be coming. Anyways, so here's this thing, and I'm animating the noise. So this should start to move around. However, I don't want to be seeing my other stuff. So I'm just going to hide that object. Actually, I'll come up here and just hide the sim, and we can look at this. Yeah, that's fine. That's fine. We can do that. All right. So now we've got our curve here. Now I can ghost this. And let's see how that looks. Oh yeah, we're jumping all over the place. Let's hit the little stop, or the little clock down here, so we're not going too fast. It's way too jagged looking. So let's change the element size here a bit. Probably want it to be like bigger like that. Give it a little bit of like dancing around motion there. Cool. It's kind of fun. Maybe we'll do 2. I don't know. Could that be too much? Yeah, it's a little too much. Let's do 1.5. Yeah, we got a dancing tornado. All right, we'll keep this at 4. Let's change the amplitude to 1.25. We don't want to go too crazy. Let's actually maybe turn our pulse duration up, I believe. Yeah, let's do maybe 1.5. That won't be quite so fast, and then we'll get a nice little wiggly thing going on here. Maybe the element size is 5 instead. 4.5. Sorry, I'm kind of guessing on these values here, just looking for something that looks good. Cool. Okay, that's looking good. I mean, you can play around with this stuff and figure it all out. Just remember that the one thing that was kind of important here was the noise along vector. Because they're emulating the mountain stop, they're expecting you to have kind of just a flat plane that has geometry that has normals that it can calculate. Unfortunately, this is a curve and it doesn't have normals, and I want it to go in all the directions. So that was why this was maybe a little off. I could also use a point jitter, I think. Yes, I could do that as well. However, this has got a lot less options to it. So I like the mountain. It's got some nice attributes in it. So let's do a null. We'll call this out vortex axis, because this is where the vortex is going to happen. So let's do this. And that looks good. I feel like actually, now that I'm thinking of it, there needs to be some properties on this, if I'm remembering correctly, from some pop stuff that I've done. Well, let's see. We'll go into our grains. Got our curve there. Turn off these points. All right. So we're going to use a pop. What is it? Pop. Axis force. That might be it. That might be the one. That might be it. Let's take a look at this. No, I don't think that's right. Okay. Oh no, this must be the right one. All right, so let's do this. We'll do a SOP, and we will grab the output of that vortex curve. Except, let's do this. Yes, so I think this does need some properties to it. So let's open up the old handy dandy help card here and see what we need here. Oh, that's the one I want. Pop curve force. Sorry. I think that's what I want. Yep, that seems more accurate. All right. You know, this is what I get for doing this stuff on the fly. I forget which one I'm looking for. There we go. Look at that. That is just exciting. Oh yeah. We got some stuff going on here. I don't know what it is, but it's happening. We got particles moving. All right. Great. This looks just great. Okay, cool. So we got some nice little indicators here, which is going to work in our favor. We can see there's arrows here that are saying it's going up. So that's good. So I think if I do this to 10, it's going to start going up. Sure enough, there it is. Launch it into the air. I don't think that's exactly what we want. Let's see here. Maybe 5. It's just too much fun. Oh, that's great. I love it. Okay. We're getting somewhere. I'm going to turn the guide off, actually, just to make it a little easier to see. It seems like we've got a lot of craziness going on there. Actually, I wonder if I can... Oh, you know what? I could just do that. I could do show curve only. Perfect. That's better. That's a lot less difficult to look at. Okay, so there's a couple things to keep in mind. We've got our max influence radius here. So I believe if we set this up to like 5, we're gonna get like this whole. It'll restart. So we're gonna get like the whole thing like going up into it basically, which is cool. I mean, that's probably what we want. Something more along the lines of that. I mean, maybe it's not quite that much, but something along those lines is what we're hoping for. So. Let's maybe set this to like maybe 3.5, something like that. So follow scales at 5. Suction scales should be what's coming in. like sucking it in towards the spine, and then orbit scale will be going around it. So just for example, if I set this probably to 5, it'll probably start swirling around like crazy. So we'll start to have this swirly behavior, and that is certainly what we want. However, now we have the other problem of the suction force, or the follow scale is not high enough. So it's sucking it around, it's doing all this stuff, but it certainly is not doing what we want it to yet. So actually, you know what? Let's just play around with something here. What if I did this, and what if I up the air resistance a bit instead? See if that'll see what that does. I'll treat it as a wind, I don't think. Maybe. Huh, interesting. I was actually thinking that was going to be, 1-to-1, but that's okay. We can kind of keep playing around with this here. So let's bring that up like that. Okay, cool. It's starting to work. Let's see, maybe 3, something like that. And let's start to do some orbit. Let's do 5 on that. So you can see that the orbit is actually pushing this out, right, to the outside of this. And you can see that this is actually starting to really like lose a lot of particles down the bottom here. And that's kind of what I was wanting to avoid, was this kind of look of it like sucking up all the particles down there. So we'll tweak that in a minute, or in a little bit. But there are these down here as well, which are different fall offs. Those all look fine for right now. Let's do this to like 10 maybe? I don't know. Too much. Let's do 8. Maybe this will be 10, something like that. I don't know. And we'll have this at like 5, maybe something like that. I don't know. Go. All right. So now I'm seeing what my problem was before, was I didn't have that suction force on. And so this follow scale actually probably falls off away from the curve. So that is part of it. So the further it is, the less it's going to follow. So let's turn this down. We're kind of balancing a bunch of stuff here, so we'll see. We'll see where this goes. And there goes all the particles up into the the tornado. Maybe we'll do this a little less. I don't know. Maybe it doesn't need to follow so tightly. It does look nice when it's like coming up like that. All right. So we've got our orbit scale here. Let's maybe even go a little crazier with that. Could definitely go with some higher spinning forces. Yeah, it's starting to get somewhere. It's starting to do something fun. But see, here's my problem down here. You got these particles, and it's like we really want those to, kind of come up a little bit more and have a little bit more to go in there, but they're all sucked in. So what we probably could look at here, actually, let me go back up to the... Yeah, let me turn these guides back on just so we can see that a little bit better. So we'll turn this on. There we go. And looks pretty funny. Let me see how this looks, like if this will show us. Yeah, okay. So well, this is good though. We have a force along length. You can see that by the brightness of this here, and it actually falls off towards the top. So if we select this point and bring it back a little bit, it'll actually fall off towards the top anyways. And then they'll kind of fall back down and kind of have like a rotational thing going on up at the top there. So we can play around with that if we wanted to. Let me bring that back up maybe. If we brought this to like 1, you can see you can see how much of a smaller area that is working in. And the reason that these are probably getting shot out is because It's because they're colliding on the interior of that, so they're probably all trying to occupy the same space and just getting spit out. Oh, that's funny looking. So that is probably not what we want. We probably want a little more than that. So we can kind of see what sizes make sense here. And I believe there is a way that we can actually, I believe there's a way that we can change the shape of that randomly, like using point attributes. But what we could do actually instead, this will probably be easier to do, is if we did the suction force, that's from the curve, but we want it along the curve. Yeah. So, yep, that's what I was looking for right there. So what we could do instead is have it just be a little bit smaller down here and kind of come wider at the top maybe. So that'll probably be a little nicer. What I'm going to do is actually just shift click all of those and change them to a B-spline. Just be a little smoother, a little bit less of a rough way of doing this. And in fact, now we can actually probably set this up even a little bit higher, and that should be more of what we're looking for. So there we go. Something like that will look a little bit more like a tornado, I'm hoping. Yeah, there we go. That's looking a little more tornado-y. So this is interesting. It is actually resampling this curve as well. So we could have that on, we could have it off. This is actually creating quite a few more segments to it. But yeah, we could actually just turn this on and just maybe do 0.25 or something like that. That'll be a little bit better maybe. So yeah, so now you can see that we're actually only sucking up these particles from a small area down here. And that's where we can then add some of these particles back into. So let's try that. Let's try playing around with that a little bit. So let me turn off, where is that? I keep missing it. There it is. There's the guides. We'll just do the curve only. Great. Yeah, we got a tornado. It's looking good. All right, so we have this curve force, all this stuff here. All right, so we got our Vellum sim. So the thing that's tricky about working with a DOP network like this, especially if you're using it like straight in context, like you can come up here and do a DOP network and do this, you know, and then have everything, you know, source it out to other nodes and stuff like that. But if you're using it straight in like a geometry context like this, you want it to come out the bottom, right? So if we put a null down here, you know, you want to bring, you know, we can call this like sim results or something like that. And so this is what we'd want to see, but I think you can see that there's an issue. We've got a few different problems going on here. If we hide the other geometry here, now the spline in the middle is not there, but everything else is coming in, which we kind of don't think would want. So there is a tricky little thing you got to do here, which is under this object. So what we want to specifically call is this Vellum object. So we could call this, why don't we just call this grains? That'll be a little easier to kind of name. So I'll just go back here. And, oh, did we get a viewport bug there? We sure did. Look at that. Oh, we got the viewport bug. That's too bad. You know, it's probably the one thing that Houdini really screws up every so often, and that's okay. We can fix it. If you run into this problem where you're like changing nodes and stuff like that, and you're like, shoot, oh, well, there it goes. It went away. Oh, no, there we are. We're back to this. Okay, so if you run into this problem, help, reset viewport should do it, I think. Oh, hold on, we're back at that. Yep, okay, I think that should do it. So now we're back to where we were. The problem was it was like sometimes stuff will get kind of like stuck in the viewport almost, and you can't like turn it off or hide it. So anyways, you might have heard me say that before, but Okay, so right now we have star, and basically that's just a wild card saying everything. So if we say nothing, then nothing should come out, but it is coming out. So that's kind of weird. But instead what we can do is do star grain star, and that will only bring out the grain particles because we called this object grain or grains. So we can change that to grains. And then if you have anything else, any other objects that are like grain objects that are named that, those will come out as well. So, so there we are. So there's our sim results. So I'm going to do something maybe that it feels a little weird to me, and maybe it'll work, maybe it won't. But I think it should. So let's fingers crossed this should work. But I'm going to try not to make an infinite loop here and freak Houdini out at the same time. So we'll call these initial grains. Oops. If I can type, that would be good. All right. So initial, something's going on here. All right. There's my initial grains. So I'm just going to make let's just make a reference copy of this. We'll do actions, create reference copy. So that'll just be a secondary copy of that. Great. So we'll call this replenish grains. Let's see if this works. I don't know. We'll see. Okay, so I'm going to take these same created points here, but I am going to do an object merge right here. It's this is going to honestly just hopefully make this a little cleaner. Get last. Let's see, get sim last frame, just so this is a little clear as to what craziness I'm doing. Let's bring this sim results up here. Okay, so that's working. We're good. So let's do our let's do a what's it? Time shift retime. We could just use retime. Let's do by frame. And all we're going to do is just say FF -1. So right now we're on frame 0, and we don't want that to extend. I don't know. Let's just do this. RF start. That'll give us our start frame, and we'll do RF end. That's just basically saying the preview area. Okay, cool. So right now we're retiming. So we're getting the previous frames results, right? So if we go down here to, well, if we just hit play here on this will show us our sim frame. So if we go here to, let's just say 72, we'll stop at 72. So this should actually be frame 71. If I come down here, you can see it goes one frame forward. So this is one frame backwards. So I just want to see if there's particles on this, basically on this previous frame here, because if I'm checking on the current frame, that's going to just create a loop that's never going to get resolved. But I want to look one frame back. So this retime should help us do that. Let's take this create points here and let's do a point wrangle. This might get a little crazy, but we'll see. We'll take this here. So those are our points. And then these are our retimed points here. Let me just make sure we're good here. We got P scale on these, right? Yes, we do have P scale. Okay, so what I'm going to do is I'm just going to do an attribute delete here. We don't need all these crazy attributes. It's going to be just a little obnoxious to maybe have to look at all that huge list. So let's just take the stuff we do need. So we'll take P, we'll take P scale. Actually, I don't even need this retime now that I'm looking at this. We have P last, which is interesting. And so we could use that. No, we'll do this. Sorry. Just thinking that maybe that could be done as well. We could probably figure it out with P last, but I think it'll be easier to do with P scale. Neighbors we don't need. Just looking if there's anything else we might need here. We'll just keep velocity just to keep it. Great. Looks good. Okay, so those are all we're going to keep. We're going to delete the non-selected. There we go. We just have points. This should be fine. So the nice thing about doing this is actually going to kind of set these back to just straight up points anyways. There is also, see this detail attribute GL sphere points. That's what's creating the fact that these all look like spheres. So it's actually going to be a little probably quicker to even evaluate and stuff like that. So we can just see those. Cool. So that's looking good. And I'm going to bring this down here. We're just going to put that in there for now, just to evaluate that. Those are going to be the grains that we're evaluating. But let's get here. So here's what I'm thinking we're going to do. We're going to look and see if there is a particle that's within the p scale radius of all these points. So we're going to work over all these points. So we have p scale for these already. So if we look here, we can see we have a p scale, and down here, these are all 0.075. And so what we're going to do is we're going to take that p scale and we're going to double it, because then that should give us the maximum radius to look within, right? And so pretty much if we find a point within there, we can know that we can remove these, because we know that they're all the same exact p scale. There is none that are set. Geez, I need a new one of these. Sorry. Anyways, so we know that there's not going to be any points within that sphere if we double that p scale, because they can't both coexist inside of that. Now we could give ourselves a little bit of buffer too and say like 2.5 or something like that. To be the distance to look inside of. So we have this, and we actually might be able to do this without even needing to worry about any of these attributes, but we'll see. We'll see what this comes up with. Actually, I'm going to go to frame 2 just because from this frame there are actually points. So none of these points should come up at this point. Let me say the word point a few more times. So nothing should show up. So we have these that are starting to move here. Everything though should be within one radius, within collision radius basically of each other. So these should all get removed. So let's do that. Let's look. PC find, I want to say, is the one we want to do. PC find within a radius. Let's see. Let's just double check there. Yep. So we're going to do PC find radius. So this is going to let this. Okay. So I'm trying to think through this a little bit on the fly. So what PC find would do is PC find in and of itself has its own function. And basically this gives you a list of closest points, right? So from an object or from a geometry. So with this, we would actually have to, we can set it up to use, the position channel and all that stuff, and use a radius and tell it the maximum number of points to return. But what we'd have to then do is look up to see if that array has any points in it that it's creating. So we don't actually want to do that. Let's do near point. And that will be what we want to do, because if we find a point within this doubled radius, then that will return the point number. If not, it's going to return a -1. So that is the condition that we want to look for, is this -1 condition. So let us do that. So let's first do, we'll do search rad like that, and we'll do at p scale. So we're using the p scale, and we're going to multiply that times, let's do 2.25. It's just a guess. And we'll call this, this is going to be a float. So I'm just going to, I could type. So this will just create a float attribute on this wrangle node. It will not create an attribute. If we wanted to, we could do f at search radius like that, and that'll show what the search radius we're going to be looking within is, which is search radius, I guess, which is 1.16875. So that is 2.5 times that. If we change this to 2, you can obviously see that would be 0.15, and that's double. Anyways. So sure, we'll do 2.25. That's fine. Just want to give it a little extra so that it'll find if there's a point just outside of it. I don't want it to be colliding, I don't want it to be like one that's just barely touching and then it resolves and goes shooting off into outer space. So let's try that to start with. We can always play with it from there. So now we're going to do int. We'll call this found point, because this will give us the point that's closest to it. And we'll call this equal to near point. And the geometry is 0 because we're working on the current geometry. And we are going to do, what is the things it's looking for? It's looking for a geometry, a vector point, and a max distance float. So I'm going to change this back to float. And so we're looking for, again, the geometry, a point, and the maximum distance. So let us, so this will actually be looking for the point position. Yeah, the point is the position in space. So we'll be using position for that. So we'll do 0, we'll do v at p, and then we will do search. Man, my typing is off today. Search radius, like so. There we go. So what we can do is we can just to check it real quick, we can just do a found point. And sure enough, these should all find themselves basically because they're all the closest point to themselves. Oh, my bad. It should do near point of 1 because that will then be looking at input 1 instead of the current input. So that's my fault. We want to actually look at source 1, but it still should find the same index point. So let's go through this a little bit. Let's play this through and we'll let it go down here somewhere, somewhere down here. Now this isn't changing, but this is. So let's look and see if we're finding still finding points here. Those are all still finding themselves, but we do have some -1s now. So there are -1 points right there. You can see a whole bunch actually. And my guess is going to be that those are the points that are in the middle here. So actually quite a few. I'm scrolling pretty quick. But there's a ton of them, so we don't need to go through all 16,000, but there we go. We got some -1s. So let's go back to, we'll just change this to an integer. We don't need that to be an attribute that gets saved. So let's do found point, and we'll do this. We'll do an if statement. If found pt is greater than -1, we'll say remove point, and we're going to remove point from the original geo, and we're going to do at pt num because we want to do the current point that it's looking at. So let's do that. And sure enough, look at that. As those as those points get sucked away, we have more points that are ready to kind of come into the wings here and get sourced in. So that's kind of fun. I mean, this hopefully will do what we're wanting it to. Let me just go to the end here. Let me up my cache a little bit here so this doesn't go back on me. Oops. And let me just go to the end here. Let it sim the whole thing. 3, 2, 1, sim. Cool. All right, so there we go. We've got all of our points, and this should actually be more or less the exact opposite of that, which is kind of interesting. So if we do this, we pretty much have this like mirror image internal like missing section here. In fact, I bet you I actually went too far here because we're missing some there. So let's just change this to like, let's see, 0.1. Yep, there's a couple more there. We could actually just do 0.1 or something just to kind of push it a little. And there you go. Now it looks like it's completely just normal and nothing has been perturbed. So This might work, this might not, but let's give it a shot, see what happens. So what I'm going to do, there's those replenishing grains. These are all set up exactly the same as this initial grains, because we made a reference copy, so that's completely like duplicated. And I think what I'm going to do here is just pipe this into this fourth context geometry here, and hopefully this is not going to freak anything out right now. So let's do this. So right now we should have, if we look at this, there should be the whole thing, right? But then if we go to frame 2, there's nothing here. There's no points getting sourced here. So that's good. We know that that's good. And what we can do is we can actually, I'm just going to do a switch. So this is a switch off. This is a QLab, QLab node, just a nice little thing to just kind of turn itself off. You could do the same thing with a switch and change the input, but it looks like this normally if a switch inputs it with a null and the input here in that case. So I'm just going to have it be set to, let's see, I'm just going to do $F is not equal to 1. And this should return 0 right now. And then if we go here, it'll turn back on. Great. So there are our particles. I think I'm actually going to turn this back up a little bit. Sorry, kind of keep waffling on this a little bit, just so it doesn't, you know, you have returned. Welcome back. All right, so here we go. We've got these points over here that we're creating that are in this kind of missing area. And so here we're going to go back into our Vellum sim, and I am going to do now I'm going to do the Vellum source because that's what we want to be doing at this point. And we're going to put this into this node here, and our SOP path, we can actually use the same thing that we used over here. We can just do op input path. We'll copy and paste this and paste it like that. And this will be 3. And now we shouldn't actually see anything right now. And if we do each frame, that should work as well. So let's see what happens here. Interesting. What happened here? What did we do? What did we do? We broke it. Particle density. That's odd. Why is it doing that? That's working. Oh, that's too bad. That might not work. Why would that not work? Let's see. What about that? All right, let me just go back up here. Let's try something else. Instead of doing that, we can leave this. Let's just do a null here. Put another one over here. Call this punish. Don't know if we'll need both of those, but maybe we do. All right, so forget this fancy way of doing it. We'll just straight up source it from those. So we'll do replenish constraints. I don't think that's going to matter, but we'll see. Set that sim. All right. I have another idea actually, because I was just reading something here which sounds like this might actually have that check built into it. So let's see if it does. All right. So instead of doing it this way, I'm going to turn this off and turn that off. And the initial geometry will be instead, we can just do geo and con like so. Why is this freaking out? What's my error here? Infinite recursion. Thank you. Yep. It was mad at me. Didn't like that. That's okay. It was worth a shot. But maybe we can make this work anyways. It was kind of a fun thing to do. Guess if you need to do that in the future, you'll know how to. All right, reset that sim. Let's see what happens here. It's not, unfortunately, that is not instancing it. Oh, that looks like that's actually doing it now. Huh. Well, there you go. Interesting. I did not know that this actually had a built-in check. So what I have learned here, and what you can learn as well, is you should probably read that. And it does actually have, it says it checks the density of new particles against existing particles to avoid having too many particles in one place, causing large outward velocities, which basically just means it's checking to make sure, just like I was doing there, that there aren't going to be interpenetrating particles on top of each other. So what we can do is do something like, I don't know, 0.75, and that will now replenish this like section here basically and add in particles as it's going up. So this is going to make sure we have a nice thick, crazy simulation here. And it won't let it get to that kind of spot where there's like a hole coming in, so that should work pretty nicely, actually. Look at that. That's working out fine. Yeah, so if we wanted to do 0.5, that'll make it less dense the way that it's kind of emitting new particles. And you can see that this hole is getting a lot deeper down here. So that's something you can kind of use to control that, actually, which is pretty cool. Pretty nice that they have that built in as well. So yeah, so there we go. We got the Vellum tornado going here. Let's try a couple other things to make this look a little bit more interesting. So let's do a merge node here. We can kind of put as many pop force type things in here as we want to. So let's do like a pop wind. It's usually a nice thing to add in some noise and stuff like that. So here we've got our amplitude. Well, let's just set it to 1, see where that gets us. Oh, look at that. You can actually see some of those particles sourcing in there. Just doop, bloop, bloop. They're just kind of like dropping in. You probably wouldn't notice it too much, but it's a little noticeable, I guess. Yeah, I probably will. I don't know. We'll see. We'll see with the particles. Probably would make some sense to kill some of them off. I hadn't really thought of it too much, but yeah, I probably should. Sounds like a good idea. Yeah, no, grains, particles, it's all the same thing basically. I mean, really the main difference is we're we're just seeing the sprites here. But if you looked at them, you know, if you looked at them from a from a point standpoint, they're all the same. So okay, so we got our particles coming here. Yeah, that's probably a good idea. Let's take a look at our solver here. Can we? Is there anything that they have built in that will just kill them? Grain collisions, those are good. Probably not, actually. They probably don't have anything built in here. So let's do a pop kill. Okay. So I have an idea first. So let's do something here. So we've got our pop wind, and I want to do this to like even more. So like maybe it's like 5. I don't know. We'll see. Let's see how this looks. Now, obviously this is getting crazy down here and is not working, but I just want to kind of look at this up here and see where that's kind of going. And I think this is going to give us a lot more interesting movement up on this side of things. Now, obviously these points are losing their minds down there, so we don't want it to do that. So let's do this. Let's do a pop. Oops. Pop wrangle. So these are going to evaluate from left to right. So I want this pop wrangle here. And I want it to do, let's see. Oh, can I do, actually, sorry, let me just think of one thing here. Can I do, instead just do a pop group? Yeah, I bet you I could do that instead. There we go. Perfect. We'll just do that instead because I just want to set up a group, and we can set up a rule. And I'm going to say, let's see here. If length of v at v, which is just going to be the speed, is greater than, oh, I don't know. Let's say 0.5. I don't know. I don't know what speed we're going to do, but let's just try this. We'll say in group equals 1. That's what the thing said before. So let's try that. We'll turn them blue, it looks like, if they're going to. So we'll call this group moving points. And we'll just put this in here. Ooh, doesn't like that. Must have missed something. Ah, yes, I did. Missed a parentheses right there. Boom. Right. In. Man, my typing today. Whew, not good. In group equals 1. All right, great. So let's move this up. Doesn't seem to be. Now, let me just try one other thing here. Make sure it's something I'm doing that's actually causing the problem. Oh, you know what? This might need to be over here. That might be my problem. Let's just check that out. Oh, interesting. This is actually putting them in the group, but for some reason it's not changing color. Why is it not changing color? I have a guide here. Do we have something turned off, maybe? Maybe. Yes, no. Weird. Weird, weird, weird. Yeah, so you're saying this flag here. Yeah, that should not be the problem, I don't think, because that's really basically saying your export. The flag, sometimes flags do matter if you're like have them off here, like the bypass. Um, but it should be. It's really strange. I'm not sure what's going on there. Let me check here. Basically, I just want a group of them that are moving. And for some reason, it's not doing that. Let me just check here. Moving points. Okay, they equal 0. Yeah, right. Yep. Makes sense, yes. SOPS does have that. Okay, so this does actually look like it's doing what I want it to. Now it's actually adding things into there, it looks like, maybe. Let's see. Maybe not. I don't know. Confused. Confused am I? Let's see. Anything in there? I'm just looking at my... Okay, so we've got 0 in the moving points. Let's do this. Let's do a color, pop color. We can just do this. Okay. We can do group. We can say moving points, and now we can actually see when the moving points are being added. Great. Let's try that. Just do something really bold, like red. Okay. Well, that's working. Oh my goodness. That is weird. I do not understand that at all. Huh. Okay. Well, that does not seem to be working. Let's see what we can do here. Can we do this again? Enable this. Okay, that might be working. Let's see. All right, there we go. So what I need to do is maybe have both of these in line here. So these are just getting evaluated on this one chain. I'll turn off this pop wind for a second. Yep. And here I will just do group. Okay. Think we got this working now. So what I needed to do there was I'm just setting the pop group on this chain and also coloring it just so I can see which ones are moving. So that is all working fine. Let's come over here and set the group to moving points for this pop wind as well. That should, so now if I don't set this, it shouldn't do anything. There should be no noise on anything, which is good. That's what I want. So now I'm going to turn this off for a second, turn these two back on. So these are going to now put it in the group based on how fast they're moving. So I don't need it to go to 5. Let's try 1. So this is basically the speed of the points. Like if the points are going faster than a certain speed, they're going to get put into that group, and they won't be affected by the wind until they're in that group. So okay, so we're getting too many of those down at the bottom there. So let's up that a little bit more. Let's try 2. Let's see here. Yep, that's looking good. Something like that should work just fine. Let's turn this on, and that should hopefully not be perturbing anything, and it still isn't. Beautiful. So now we can up the amplitude of this like crazy if we want to, and that'll really add in some noise. Now, unfortunately, that is starting to move some of these down here that have gotten perturbed. So we might want to just change this a little bit more. Let's try like 2.5 or maybe 3. We don't want to go up to 10. Maybe we can do like 7.5 just to give it a little less. So let's see. Okay, cool. So now we can do the same thing with the pop kill, and we can use, just move this up a little here so we're not overlapping. So now the pop kill can look and say randomly, let's just give it like a 25% chance of being in this group here, moving points. And so it's probably too much. Let's do 0.1. And so now that'll just give it some randomly kill some of those points out of there. Well, let's see. Let's see if that looks a little better. So we'll let them kind of die off every so often. Let's see if we can see how many points we've got here. Yep, there's more coming in. Just see here if we need to set up a yeah, no, that's a great point. I like that suggestion as well. So like, yeah, what you could certainly here in the pop group, you could do yeah, we could say actually it would have to be just greater than 0, right? So we could certainly do that. We could do double and we could do at p dot y is greater than 0. So now, yeah, like you were saying, that should only put things in that are above this 0 point here. So we won't have any of these weird little ones down at the bottom, which is great. It's a really nice idea. Will it actually take them out? Sure will. Looks like it will. So if they drop back down for some reason, they'll actually get taken out of that. Let me try this here. Let me try doing, let's just go crazy with this. Let's do like 7.5. I really thought that this was going to kill these off. Oh, it is. Oh, there we go. Okay, it's working. Guess it just is really finicky. Very, very tiny values that are that's really bizarre. Yeah. Yeah, it does kind of look like they're lifting each other. So what I could do is maybe give this a little bit more. Let's see. Let's try a little bit more of this here. Let's try 7 on that follow scale. Let it really pick it up quite a bit more. Try this like 8 on the suction. Maybe that'll be a little bit better. Turn this on just to kind of see the movement of these. Yeah, it's kind of interesting. Let me look at the guide on this. Maybe this is a little too crazy, maybe. Something like that. Make some swirls of maybe a little bit. Yeah, there we go. So what I'm going to do is I'm actually going to come up a level here, take a look at these sim results, and maybe I will, let me turn this off. Don't need to see that. Just do attribute delete here. Just kind of kill off that sphere. Just color back to maybe white. Just want to see what this swirling motion is looking like here. Probably freaking out on the stream, but looks kind of cool. It's got some neat, interesting interaction stuff going on there. Okay. So I think what I'm going to do is one more. I think I'm going to just do a. I think instead of doing this pop kill, I think I'm going to do my own age thing here. Some sort of age pop. Is there like a life, anything like that? Just thinking through if there's anything else I could use. Kill limit. I think I would like to do some aging. Great. Yeah, thank you so much for joining me tonight. Hope you enjoyed it, and if yeah, I'll probably be finishing up within a half hour, something like that. But if you if you're interested in checking the rest of it, it'll be up on YouTube and Twitch. So thanks for joining me tonight, man. Really appreciate it. Let's see here. Let's look at these pops one more time. Just looking to see if there's any built-in nodes that I'm not thinking of that'll help me do this instead of having to write my own thing, because a lot of times they have these things figured out, but doesn't seem like there is a specific one that I am seeing. Which is fine. I'll write it myself. No problem. All right, so let us do this. So I'll take this out. We don't need that, I don't think, anymore. That's not really doing what I wanted to anyways. All right, so here's what we're going to do. We're going to do a, we'll do float age equals, and we're going to do a channel for this. We'll say particle, let's call this particle age. And so the reason that I'm kind of running into these things is because Vellum, it doesn't really want to have an age to the particles, basically. We could do this in grains as well. You know, Vellum just seems a little quicker to me, but we could have done this in the with just a straight pop solver and a grain network. It's possible as well. So it this one just doesn't have the age stuff really built into it. Had a Google. Yes. Nice. Oh, look at that. I get a little Google backup. Thank you. Yes, it does seem yeah, it does seem like it's a feature that should be on PopKill, but you know, it's all right. The pop like I said, the pop solver itself has that built in. So I think the Vellum solver is just anticipating that you don't want to kill particles, so that's why you have to kind of mess with it this way. So this is why having something, you know, kind of setting up a DOP network like this will be better. So oh, you know what? Actually, what I'm going to do is do life, not particle age, particle life. And then we'll do float life var, which is just going to be equal to channel particle life. You know, we'll just call this life variation. Cool. All right, so we should have those two now. So we'll call this particle life. Oh gosh, I don't know. Let's do like 2 seconds. We'll give it the life variation of 1, maybe 4 and 2. Let's do that. Give it some randomness and allow it to be able to kind of move around. So we have life and life variation. Let's just do a calculation of that. Sorry, just thinking of how I want to do this. I want to do a random in here. So let's do that. No, CH is just a float. CHF is yeah, if you do like yeah, CHF is just specifically saying a float. CH is just, it's just basically just randomly, you know, it's just giving you a float value as well. There's not a real difference. It's just this is kind of like the default. And obviously if you're doing CHI, CH ramp, all those kind of things, that's kind of setting up the specific types basically. So that's the real difference. Yeah. All right, let's just do a let's do a float random seed equals and we'll just do it based on ID because these should all have an ID. Let me just double check. Should, right? No? Do they not? Huh. That's crazy. They don't have IDs either. Huh. Oh, there we go. IDs. No. That's just setting them. Huh. Okay. Guess we don't have IDs for them. That's wild. All right, we'll just do PT num. No problem. All right, so we got that random seed. Then we can use the life variation. We'll just do times random seed. So actually, sorry, we'll do fit 0, 1, random seed. And we're going to set that to, we'll just do -1, 1 because we want it to go either direction in that amount. Technically, we want it to be the variation of 2 either way. Yeah, okay, that's right. Sorry, just thinking as I go. All right, so life variance, that's good. There's our life and the life variant. So I'll just do just another one here. Float life calc equals life plus life bar. All right, there we go. All right, so we're just going to do each frame. We'll just have to add the age in. So that's easy enough to do because we don't have age here. So let's just do a age. So we'll just do f at age equals, what is it? You know, I always forget this. So it's in here. What is the name of it? Time Inc., I think is what we want. Yeah, I think so. So it equals at Time Inc. And I think that's going to do what we want, which age is at, right, like that. Yep, perfect. Perfect. It's doing exactly what we want. And then let's just see where our life is here. Let's just do, we'll just call this f at life, actually. This will be our thing that we save out. So there's our life calculation. There we go. So we'll just say if it's greater than, or sorry, f at age is greater than f at, actually, no, I don't think I have to specify that f there. Time Inc. There you go. Sorry, I missed your missed your message. I used my little cheat sheet in the pop fop. Life. I think what we want to do is set this to dead. I'm pretty sure there's a dead attribute here. Dead. Yep. I at dead equals 1. Let's try that. Let's see if that works. Yep, it sure does, but it's killing all those down there too. That's right, I wanted to set the group moving points. We don't need the still points to be getting... Oh. Well now. Well, that's interesting. Yeah, the pop fop thing. Yeah, it is a nice little, it's a nice little thing to just pull up and be like, shoot, what was that? What was that built-in attribute that I can look up? Oh yeah, timing, frame. Just even like this, like num VTX. Like I forget like that you could look up that, you know. Okay, that is really odd. I'm kind of surprised by that. Keep doing that. Think about this. Why on earth would it be doing that? Really surprised by that. I would think that that would stop it completely. Yeah. Yeah, that's a good point. Check after the second frame. Let's give that a shot. One. Set this sim. See if that helps us at all. Nope. All right. So. Let's try. I'm just gonna give this a shot. I know this probably won't work, but let's just give it a shot. No. All right, fair enough. It's worth a shot. Hmm. That was an interesting one. I was not expecting that. All right, so maybe try. Let me just see if this should go over here. Maybe that'll do it. Solve. Nope. Hmm. Oh, maybe that's the problem. Let's do this. Instead of doing this, let's do float. Let's do the same thing. Float life calc. And instead here, let's do life calc. Let's see if this fixes it. Yeah. So I think problem. There we go. So the problem that was doing was that it was it was actually creating that life attribute on all, on like all of the points basically. And for some reason it wasn't just limiting that calculation to just the moving points. Now it is, and you can see that it's killing them off right at the top there. And so if we did it like 2 and 1, now they'll come up and they'll only be up there for, some of them will be up there for less than a second. So here's 2 seconds. So they should almost all be dead at that point. Sure enough, they are. So now we could do like 5, like maybe 5 2.5, something like that, and that'll give them that attribute. And the other thing that should be happening here too is that the age is not being calculated if it's not moving. So I think what was happening before was maybe that it was doing that life calculation, and some of them were calculating negative, I think. And because they weren't actually in that group, so that by default they might have been just going negative. So that could have been very, very well could have been what was happening. So let me just put this back over here, Remove this. We don't need a merge there. Can bring that back down. Hit play. That should work. Great. So, all right. So we've got that going. That'll kill off some of those particles randomly as they kind of go up into the sky, and they're not just gonna, we're not gonna have like a bajillion of them. Cool. All right, let's go back up here. So there's our sim results. Let's see. Geo ground, we can do the collider, and we could do this. Sim grains, we don't need to see that. So let's see what happens here. So another thing that I was kind of playing with the other day, thank you, I think it's looking pretty nice as well. The other thing I was looking at was this. Yeah, right. That's all Houdini, right? It's like, well, I don't know exactly why that worked, but that worked. So cool. Let's see here. I think this was what I used, and it was kind of neat to see the particle trails. So let's see if this works. It's kind of a neat little node here. To do. Let's see. Whoa. Oh, that's not liking that though. Shoot. Ah, that's too bad. I wish it had the IDs. That would be really cool looking. How can I set up IDs here? Do we have an ID? Yeah, thank you so much. Have a great night. Thank you for joining me. See if there's anything in here. There might be something for IDs. All right, let's see what we can do here. Mm-hmm. All right, so I think what we can do here is think we could possibly do a little thing to set. All right, so I'm going to call this age particles. Yep, let's add a XC at the end of that. That's perfect. All right, let's do another pop wrangle. Let's add this over here because this is post solve. So this will be hopefully the last thing that will run on our whole thing here. So let's do this. Let us do a let's see if we can do an ID calculation here. So let's do I at ID okay. Just trying to think. Just trying to think here. All right, so I'm going to do one other thing here. I'm going to, this is the geometry that's coming in. So I'm just going to do an attribute create here. I'm going to say next ID. We'll call this. So this is a integer. Its default is 0. Value is 0. That's right, because that's going to be the next ID. So let's come in here. Hopefully this will have it. Let me just reset this. Interesting. Why is that not doing that? Oh, because I put it on point. That's why. Should be on detail. There we go. Next ID. Come down here, reset that. Look at the geometry spreadsheet again here. Does it not like my name? What doesn't it like here? All right, that's fine. We could probably work around this. Let's just do this as a point detail, see if that comes in. So we have next ID. Let's reset the simulation here. Go inside, look at our points. Okay, so what we're going to do instead here is for the second context geometry, or for input 2, we're going to do the first context geometry. So this should allow us to grab that detail attribute that we created there and see if we can't do that. So set detail attribute 0. Just see if I can do this. Next ID. Set. Sorry, just need my cheat sheet here. String name, type value. Set. Okay, so that's just the value. Gotcha. So just do 0 and set. Okay, cool. That's great. That will work. All right, so what I'm going to do is just do this. Let us set some IDs here. So we'll say trying to think of how to set up the IDs properly. Maybe what I could do, just thinking out loud here, have an ID thing that'll just set the IDs. Will that come in? Man, it really does not want to bring any of these things in. It's so weird. Maybe if I do this up here, maybe that'll like it better. Okay. Well, it likes that. That's at least interesting. See if that does it. Still freaking out. So if I look at these attributes here and look at the IDs, I'm just going to type an ID here. So that's really all I'm interested in right now. Probably have multiples that are the same thing. Yeah, there are multiple down here. All right, I have an idea. I think I can do this. Let's see. So this will only run. Oops, this only. This is going great. All right, it's only going to run right here. So let's try this. is ID equals at ID. And then we do set detail attribute. Do exactly what we did before, 0. And next ID. And we will do BTID because that's what we set up here. Then from there we can do set. And hopefully set us up with something. Let's try resetting the simulation. Thought that worked before. Oh, right. There is no initial stuff in here. That's why. That is why. Okay. So that's working now. Now we have next ID set like that. Do this. Let's do if at ID is less than or equal to another integer. Next ID equals detail. So we're going to get that detail attribute 0. Next ID. All right, so if we do that, and then ID is less than next ID. We're going to set it to, say, at ID equals. Next. That makes sense. Okay, I think that makes sense. And then we'll do try this instead. So we only set it to the next one if we need to. So we'll do just do the same thing here, just in case it doesn't read that back. Try that maybe? I don't know. It didn't seem to work. Sorry, just trying to do some mental math in my head here, unfortunately. Sorry, this isn't the most exciting thing in the world here. Coding on the fly. Shouldn't have tried this one, but I think this could be interesting. So we'll keep giving it a shot. So the ID just trying to figure out how to make this work. Try this again up here. So let's call this next ID. It's a detail. It's an integer. Value. That's working. Just comment that out and see if we still have a next ID. We do. Strange. Okay. that. Let's see. What I could do instead is do point ID there. I see the problem. The next ID isn't going wouldn't a detail attribute wouldn't get updated and reread back in. It would get read. Ah, yeah, that's not going to work, is it? All right. Oh well. I don't know that off the top of my head then. And I'm not going to keep you all subjected to that. My idea was to do something with some trails here, but fortunately, it does not seem like that's going to work very well, which is too bad because this can actually do some pretty neat stuff. But that's all right. We'll let that go for now. Let's see where we get with this so far. Okay, got particles. Let's do this. Let's just set the ground to be maybe even bigger. Something like that. Let's change the grains a little bit here. Let's do 0.1 instead. Make them a little smaller, but nothing too crazy. Oh, we lost some particles down there. That's interesting. How'd that happen? Let's do this. Let's just copy this parameter, paste relative reference, and we will do this divided by 2. Set it to negative so that it doesn't overlap. It's really strange. I must have just gotten lucky on the other one. Change that to maybe 0.25, something like that. So here's the sim results. You know what? Let's just get this guy going up. We'll do his thing. But I'm gonna just get this thing rendered. Do something fun with it. Just put a camera in here. It's not gonna be anything overly exciting, but we'll do something. Hey, let's do maybe like a 24, like a wide angle. I'll let this go up to 120 so we can see kind of where this ends up. I'm just now realizing I don't have, oh, that's interesting. Just a lot of extra random little guys that got bumped around there that are kind of, interesting. Let me just look at this real quick. That's okay. Do something like this. Call it good. All right. So I think what I'm going to do is let's just keep, let's delete the non-selected instead. Say position, velocity, p-scale. Oh, you know what? Do I have a pop particle process? Nope, never mind. I don't think we need any of those. Don't need any of those. Output age, we can use that. And let's see. Let's do this. We'll do maybe, no, I'm going to do an emission based on the speed. So let's do that. And we will do a point wrangle. Let's do at emit equals length v at v. Like that. So let's go to emit and let's see how that looks. So instead of doing auto, let's do min and max. So we'll do minimum is 0. Maximum let's see what those attributes look like. Anyways, let's see. It's like the highest we get to is about 16. So let's just say, let's say maybe 10 is the maximum. And then the minimum is 1, maybe? Cool. All right, so what we're going to do instead of doing that is we're going to do a fit. The length, we're going to say 0 to 10, and we're going to do this from 0 to 1. That'll be an emission attribute. And then we can change this to be 0 and 1. Oops, now 110, 1. There we go. So let's just change this to be 1. So anything under 1, maybe anything under 2. Yeah, there we go. Looks good. So now we'll have emissions based on the speed of things. It's a little crazy at the end, but that's okay. Probably forgive it. Let's just see here if we're how are we getting those particles down there to be moving if they're below? Those. Let's see. I'm gonna do this a little higher, maybe like 0.8. I feel like it's like making those points drop down too much. Let's see if we get that crazy spraying all over the place this way. We might, but maybe not. Hmm. Let's just do this. Let's change this to be to 0.25, see if that works. Maybe that'll keep us from getting any more of those crazy points. Let's do each frame, see if that fixes things. Just gonna try to see if I can fix that so that we're not getting all this craziness. It seems worse. All right, let's go to 1. Let's just see if that'll do it. Hmm. Gonna remove that. I just want to see. Okay. So we do have these. I was going to say we could maybe figure something out based on the stream that's coming in. I don't know. Well, we'll just call it good. It's kind of working. It's maybe a little too crazy at the bottom, but that's okay. I think we'll live. Let's get up to 96 here maybe. Turn color maybe. Sim results. Cool. All right, so let's go up here to a geometry node. We'll call this one render ground. And this one we will call render particles. Let's go into here. We'll do an object merge. Bring in the ground collider. Get ground collider. Okay, that looks good. We will just do a null just in case we need anything here. We'll call this out. These are going to be the render particles. We'll do object merge here. We will get sim grains. There's the sim results into this object. We'll say get sim particles. So I was just realizing a little bit ago that I don't have any of my fun renderers loaded here. So we'll just do mantra, just good old mantra. So let's do this, and why don't we do a material network? We'll make two. We'll do a standard. Nope. Principled shader. We'll do two of these, I guess. We'll do one. We'll call this points. Call this one ground. So let's come in here. We'll do render material. I'll call this shaders. And we'll do ground for this top one here, render ground. This one we will get the points. And let's also do a route network. I just kind of always like to have these things, you know, in the kind of in the context here. and the object network. I just think it's a little nicer to be able to jump in and out of them. Kind of don't like having to go up to the output and all that stuff. And I've never noticed any issue with it. So if there is one, you can let me know. I'd love to know. All right, we'll call this mantra. And we'll just do a mantra node. So for objects, I'm just going to do only render objects like such. That'll make sure that we're only looking for render for geometry nodes called render. I'm going to say physically based rendering. Cool. Object camera 1, we'll just call this like final render. See if it updated that. It did. Perfect. Great. So let's go to our render view here. Of course, I accidentally went to the wrong thing, and somehow my scene view is over here. That's really weird. Render view. Okay, we got mantra, ROP. Let's do our points. Okay, let's do this. Use point color for our emission. Let's just adjust that real quick. Because what we can do, we'll just adjust it here. So we have our emit, and what we can do is we can adjust that to our float color. So why don't we just do a point bop? Be easy to set up because we can just kind of link these together. So why don't we do our emit? So we'll just bind that in here. We'll do emit. It's a float already. That's great. So we can just do emit to CD. So there is that. Let's go up here and turn off this. We should see that that's black to white, which looks good. So we'll do emit to CD. There's our output. Great. And so what that's going to do now is that's going to use the point color to set our emission color here. And that should be good. So we can do the emission intensity to 10. Obviously, if it's black, it's not going to emit anything. So that should be good. Let's go back to our render view and let's hit render. See what happens. All right, that's starting to look like something. Let's see here. So I think the problem is I might have went a little crazy there. So let's set this back to 1 and see what that does for us. Yep. Is our ground not shading? It doesn't look like it is. That's kind of weird. Oh, I know the problem. As per usual, one of the goofy things is that it creates a headlight in here, and that's just silly. We don't want that. All right, so let's go back into the shaders. Points, let's do 10 again. There we go. It's kind of looking fun. We could change the emission to be tinted some color, like blue if we wanted to, like this. That's looking pretty cool. All right, so let's go up here. Let's look at our particles. One of the things you'll want to do is do velocity blur, because that will be helping with it. Geometry, great. Okay, so here's our mantra node. Let's go here. Allow motion blur, and let's do a few more geo time samples here, and that should hopefully give us some motion blur. Let's just go kind of crazy here. That's kind of fun. Let us also go into here and just adjust some of these things. So why don't we have our properties be a little less? That's cool. Maybe like 4 to 10, something like that. It's kind of interesting. Let's try some more stuff here. Let's see what we can get. We allow some depth of field. Back into our scene view here. I'm going to unlock the camera. And let's just look at it here and get our that. Can look at where that puts us for our mantra render here. For that, if we do depth of field, we will want to adjust that on our camera. Sampling. So let's do f-stop of like, I don't know, something crazy like 1.4 maybe. You know, the other problem I did, I set my view to be 24. So let's do like 85 instead. That's going to give us some depth of field. And then what we can do is actually back it up a little bit. So let's go back into our scene view here. Let's go into our final render. Let's back this guy up a little bit like that, maybe. Oops. Was not locked in my camera, so let's move back. There probably, and then I'm just going to pop out of the camera again and just make sure our focal length is set properly, which it is not. So let's, our focus distance, I should say, is set properly. So let's go like that. So now there we are. That's what's rendering in the background, which is probably not super happy about. Should have done it. I'm a little surprised that that's not giving me any depth of field with these particles, but I'm not seeing any fall off or anything like that. It's kind of interesting. Maybe I'm missing something. I'm just going to let this go to 120 just so there's a little bit more of those like floaty particles there from the ground. Odd. Not sure what's going on there. Well, I can't say that I am the expert either on on Mantra. Oh, hey, there we go. That's much better. Got some bouncing light here. That looks a little bit nicer. At least it looks kind of cool. Size a little bigger. Let that render out. It's looking pretty cool. Kind of like a crazy, glowy, you know, particle tornado. Kind of interesting. This will do it. Maybe it was just that I should have restarted it, and I didn't. Nope. Let's just see if there's any difference here with depth of field on or off. Kind of feel like there won't be, but let's just see. So there's with it on. That off. I mean, there's a slight difference. There's a couple pixels difference. Just leave it off. Oh man, I don't know what that's all about, but hey, whatever. All right. Well, I think that's looking pretty good. Let's do, let's just adjust the frame range here to be 120. Hit apply. And yeah, I think I'm going to render this to, I'm going to, first of all, make sure it's saving. Save that and render it to mplay. Let's see what happens here. Accidentally grabbed my background. All right, so I'm going to let that render out, see what happens. See once we get a couple frames in here. Oh, well, I'm on render current frame, so that won't really work. Let's do render frame range instead. There we go. Now it'll bring up my little interrupt thing. Let this kind of keep going here, see what happens. Probably going to be a little noisy, but that's okay. Not a big deal. So yeah, so I think that turned out to be a kind of a fun experiment there. We've got some glowy particles that are kind of spinning around and doing all sorts of crazy stuff. Yeah, we hopefully that's something interesting and you learned some things. Kind of went a couple directions that we maybe didn't need to. Dove down a couple rabbit holes, but hey, that's how you learn. So I think this is where we will leave it for the evening. Thank you guys all so much for joining me. I think we'll get something pretty neat to look at here in a few minutes. And yeah, thanks for joining me on Houdini Hangout. If you have any suggestions for stuff for me to do or for me to work on next time, you can always drop it on my Twitter feed. I'm at Houdini Hangout. My personal one is at Peter Cubic, and you can reach me at either of those places if you have ideas for what you'd like to see us work on next time or anything like that. I have been streaming on Tuesdays at 8 p.m. Eastern. So if you're interested in coming and hanging out next time, that would be the time to do it. And other than that, I think we've got a little spinning craziness here going. So I think we've got something fun. So I might post this after the fact and just say, hey, here's what we did. And yeah, I'll probably put this out on my Twitter feed afterwards, on the Houdini Hangout Twitter feed, and kind of let everybody see what we did. But that is all for this evening. Thank you guys so much for joining me, and yeah, hope to see you next time. So that is it for this evening. See ya.